So, hello. I want to talk about why I switched my installation from a sculpture-based model to computer vision. So, basically, a lot of feedback I got from people was, number one, how is this going to work? I don't know, I came up with a lot of reasons why my sculpture didn't work in this previous video, but upon testing, a lot of people were like, this is not perceptible enough. There's only a few things that you can do with this, and it's not changing in a perceptible way. I mean, the reason that it wasn't changing in a perceptible way was unrelated to the fact that it was sculpture. It was because I had it changing one oscillator instead of doing anything very dramatic. But it's also just as I outlined in this previous video, it's just not a really good measure of intimacy, not a good measure of gestures, and there's no way for you to tell if people are using your installation right. It's a very, very I don't think it's a good idea to create an installation that only accommodates for one kind of user test, and you never really know how people are going to interact with any given product. People really be doing anything, which is fine. That's normal consumer behavior, but I think by creating a computer vision installation where the most natural thing to do is to go up to it and start doing stuff on camera, that I feel creates more things that I could measure and more things that I could make music out of. So it kind of moving to the computer vision model solved all of these problems because it removed a need for physical components. It removed a need for physical hardware to measure intimacy or to measure anything. You can now do this with a camera. My MacBook camera or or any sort of webcam can now see relationships between people without any sort of hardware mediation of that. And also there's so many more parameters here that I could translate to music. So gestural movement, there's so much information that I could get from watching people interact with computer vision over a very static, this is exactly your input and output of a sculpture. That kind of makes no sense from an interaction model perspective. So I think it was really the right decision to change to this interaction model, because now I've got this world of possibilities where I can see my participants, I can see them holding hands, I can see their gestures, I can measure where they are in space, and I can create more of an engaging visual over the top of that with Touch Designer. Then this means that I had to completely just ditch everything that I did with the Arduino stuff. I just had to stop using my Arduino, even though I was really passionate about it and I love physical computing, which was disappointing. But I had to switch entirely to using Python and OSC to OSC serial communication across different channels. So my first attempts at this OpenCV stuff was really, everything was jittery and it was garbage, and then it obviously caused any sort of musical experiments I created to be really jittery and horrible, because there was no kind of interpolation, there was no sort of there was no sort of person ID, there was no sort of stability within this, which is, completely normal first troubleshooting stages for any kind of computer vision project involving people. I guess I solved this by slotting people in and out, smoothly interpolating movements, and also only sort of analyzing people within a square of interaction, so a box of about this size, just to make sure that people walking in the back of the installation wouldn't jump in and get involved. I didn't want any background noise, and I wanted people who interact with this installation to be very much at the forefront and very much looking straight ahead and sort of within this box of interaction, which is a vertical box that touches the y-axis but not the x-axis, because you can't control how close people are going to get to your camera. The first pass was done by YOLO, which was just a really quick machine learning framework just for figuring out what's there, and then deepened it with MediaPipe. The full explanation of my code is in my document.